Hello everyone! Today we are talking about quantum physics. Did you know what quantum theory is?
Well, I've heard of it before, yes, but in terms of detail, it's hard to understand it actually.
Do not be complex. Even some scientists who developed the quantum theory have never been able to understand it very well. Richard Feynman said, "If you think you understand quantum mechanics, you don't understand anything."
Is that so? Here I'm more read.
Here is the problem. Newton's physics is valid for explaining our everyday world. When they build bridges or put a satellite into orbit around the Earth, engineers use the physics of Newton and Maxwell. The limits of this classical physics only appear when we look at aspects that are not part of our common experience, such as extreme speeds or the universe of particles. To deal with the problem of large masses and high speeds, we refer to the two theories of relativity designed by Einstein. And to study the world of particles, it's quantum theory.
So, relativity is for a large object and quantum for small.
That's it.
But who developed quantum?
Quantum theory was born in 1900 during a working session by Max Planck on the light emitted by black bodies. It was then developed by Niels Bohr, who designed the best-known theoretical model of atoms, the one in which electrons gravitate around the nucleus in the same way that planets revolve around the sun.
All this is known.
It's true, but quantum physics is a very large area where you can get lost quickly. This is why we won't be tackling this subject more deeply this year. This is too complicated for you to understand. I'm a little confused and disappointed. Oh, hello!
Are you okay?
Well, I thought that quantum physics was much more than that. I really want to learn more.
Don't worry, let's go to the laboratory. I want to tell you something. Do you know that physics has a mechanic?
A mechanic?
Yes, physics has a mechanic which is used to predict the behavior of matter. In the case of classical physics and relativity, mechanic is deterministic. If, for example, we know where the moon is, in what direction, and how fast is it moving, we will be able to deduce its past and future evolution. This is what mechanic is. But in a quantum world, we discovered that things work in a different way. When we know the precise position of a particle, we cannot measure its exact speed or determine its position at the same time. This is called the principle of uncertainty, an idea that was formulated in 1927 by Heisenberg.
So how do you predict the evolution of a particle?
That's the whole problem. We do not know. I have no way of accurately determining both the position and the speed of an electron. This is the uncertainty. To solve it, quantum mechanics resorted to calculating probabilities. If an electron has to choose between the holes to pass through, there is 50% probability that the electron will go through the left hole and 50% the right one.
This seems like a good way to solve the problem.
But Niels Bohr complicated it by saying that the electron goes through the both compartments at the same time. In other words, it's found in two places at the same time.
What?
Yet this was quantum theory predicts. And if we observe the electron in the box, the wave will collapse immediately and the electron will turn into particles in one of the compartments. But if we observe it, the electron will remain in the two compartments in the form of a wave.
Wait. If I look in the box, the electron is in one compartment, but if I don't look, it is in both, isn't it? But that does not make any sense.
This is also what scientists say, including Einstein. The calculus have become probabilistic. Einstein declared that God did not play dice. In other words, the position of a particle could not depend on the presence of an observer.
That reminds me of Schrödinger's experience that was conceived to explain this phenomenon. He imagined placing a cat in a box with a closed cyanide bottle. According to the quantum hypothesis, there was 50% probability that the cat is dead or alive, just as an electron was found simultaneously in the two compartments of the box as long as it was not observed.
That's it.
Let's recap. 1. Large objects refer to relativity and small objects to quantum physics. 2. Quantum is used to study particles, but we cannot determine the position or the speed of a particle. 3. This is uncertainty. 4. Quantum mechanics is based on probability. That's why Einstein had trouble with it. 5. According to Niels Bohr, the observer has a decisive role because before we open the box, the electron is in two states, and this was simplified by the experiment of Schrödinger's cat.
Aristotle laid the foundation of science. Newton proved that almost everything was wrong. Then Einstein proved that Newton was wrong. Then quantum mechanics proved that Einstein is wrong. Who will prove it that quantum mechanics is wrong? String theory? Me? You?